Hello everyone. Did you know ARM7 processors don't actually have a division instruction? So how does a processor divide numbers like 40 divided by 6? In this video, we will build a simple ARM7 division program using repeated subtraction, just like the hardware thinks. The logic implemented here is dividend is given by divisor into quotient plus remainder. So instead of dividing directly, we are building the quotient step by step using subtraction. That is, consider this particular number 40 divided by 6. When you subtract 40 by 6, the answer is 34. You have performed subtraction once, so quotient is 1. You continue doing the subtraction until the remainder you obtain after the subtraction is less than your divisor. Now check how many times you have subtracted, that is your quotient, and whatever is the result you have obtained in your final subtraction is your remainder. This is how basic CPUs and microcontrollers understand division internally. Consider this code now. First, let's see if there are any errors. No errors, so we'll go ahead with debugging. The first thing we see here is area. Area is an assembler directive which defines a section of memory to store this information. Division is the name I have given to that section of memory. Code informs that this contains actual ARM instructions. Read only because we don't want any modification to be happening to this particular code during runtime. Entry indicates where exactly execution starts. Execution starts at the very first label that appears after the entry assembler directive. Start, dib loop, and stop are nothing but labels. End indicates the end of source file. R0 holds our dividend, R1 holds our divisor, R2 our final quotient, and R3 our final remainder. In this particular case, I have considered 40 to be my dividend and 6 to be my divisor. Let's see all these steps happening. Okay, R0 and R1 are initialized with the respective values. 28 is the hexadecimal value of decimal number 40. R2 is 0 and R0 content is copied to R3. In this loop, the very first step we are carrying out is we are comparing R3 and R1. R3 has the value of our dividend while R1 has our divisor. If R3 is already less than R1, we don't want to perform any subtraction. We immediately know quotient is 0 itself while our remainder is our dividend itself. But in this particular case, that's not the answer. Here, comparison performs subtraction and updates the CPSR. If R3 is actually less than R1, negative flag will not be equal to overflow flag. But that's not the case, because of which this branch will not occur. Hence, we jump to our actual subtraction operation, which will perform 40 minus 6 and store the result in R3. And we increment R2 so that our quotient is incremented from 0 to 1. Then we branch back to this loop. And this keeps on continuing until we reach a case where R3 is actually less than R1. Okay. Now we can see that R3 is 4 and R1 is 6. As you can see, the comparison has set negative flag as 1 while the overflow flag is set as 0. So immediately there will be a branch to stop, that is our label, and this is nothing but our infinite loop. Okay, that's all about this code.